x to the fifth plus x cubed plus 2x squared minus 12x plus 8. And I need to write them as a linear factor. And then I need to find all the zeros. All right, so how do we start off with all these guys? Start out with what? P's and Q's. All right, so what are my P's?
1, 2,
Plus or minus 1, 2, 4, and 8. And then what are my Q's?
1, 1.
Just plus or minus 1, right? All right, so how many options do I have?
8.
I have 8 options. Now, how many am I really going to have? I'm going to have up to 5. All right, linear factors of it. All right, so let's get going. So we need to write out our synthetic. So I get 1 and then I get 0. Why 0? There's no x to the fourth. Very good. All right, and then I get 1 and then I get 2 and then I get 8. And I'm looking for a 0 as my remainder. What do we want to try? 1. Why 1?
They cancel out.
Okay, they all add up to 0. These coefficients all add up to 0, so we're going to use 1. All right, that's working smarter, not harder. So then I get 1, and then I get 1, and then I get 1, and then 1, and then, 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 hey, we got a winner. All right, so right now I'm actually to a 4th degree. So we're going to do it again. What do you want to try? 1 again. Why 1 again, Skipper?
They cancel out again.
Because they cancel out again. They add up to 0 again. So let's use 1 again. So now I get 1, and then I get 1, and then 2, and then 2, and then 4, and then 0. Look at that. So right now, this 1, 2, 4, 8 actually gives me a what degree? A 3rd degree. All right, so I need to keep going one more time. So now what do we want to try? Do what?
2.
We want to try 2? All right. Yeah, let's try 2. Okay, after we do this, let's talk about it. So we get 1, and then we get 2, and then we get 4, and then we get, can I stop? All right. Now, tell me why 2 is not a good option. They're all positive. They're not going to cancel out anything if you're going to choose a positive. All right, so I would definitely not choose a positive this next time. So what do we want to try now? -1. So if we try out -1, we get 1, then we get -1, and then we get 1, and then we get, can we stop?
Yeah.
All right. So we tried out -1. Let's do a different one. What do you want to try now? -2. So then I get -2, and then I get 0. Then we get, and then, whoop, whoop. All right, so right now, I end up having x minus 1 quantity what? Squared. And then I have x plus 2, and then I end up having what? What is this 104 thing? X squared plus 4. All right. Is this x squared plus 4 going to give me any real solutions?
No.
It's not going to give me any real solutions. We're going to list this as linear factors. And how can we do that? X what? Plus 2i and x minus 2i. Okay, we did that on Friday, and we also did a little bit yesterday. All right. If that really bothers you, subtract 4, square root it, but when you square root it, you got the plus and minus going on. All right, so that will give us the 2i and the negative 2i. All right, bless you. All right, so then this is what? What's that 0? 1 comma 0. This is -2 0. This is -2i comma 0, and then this is 2i comma 0. Now, is there anything this special that happens? I really only have 4, 0, but I kind of have 5. Okay, what happens here? It bounces where? At 1. Why does it bounce there? It has a multiplicity that's even. All right. So now we have Renee's rule. All right. Trinity's looking at him like he's beautiful, so Trinity's going to read about Renee's rule.
Educate an equation and have as many true positive roots as it contains changes of sign from plus to minus or from minus to plus. Rene
Descartes.
Descartes. 1596 to 1650 in
La géométrie.
geometry.
He's French. All right. So Rene Descartes, la géométrie. All right. So he came up with this a long, long time ago. All right. He has beautiful locks. All right. Just like this guy. All right. So Rene's rule says from minus to plus or from plus. Whoop, whoop. When you put Rene's rule into practice, if you have an equation, you need to look for the sign changes. All right. So when we look for our sign changes, this goes from positive to negative. This goes from negative to negative. Is that a sign change? No. How about from negative to positive? Is that a sign change? Yes. How about from positive to positive? How about from positive to negative? Yes. So in this one, how many sign changes did I have? I have 3. And what that tells me is that I have 3 or 1 positive real 0. We always go down by 2. So if I had 5 sign changes, I would have 5 or 3 or 1. Why does it always go down by 2? Let's think about what we learned yesterday. Why does it always go down by 2? I can look over your notes. Mariah's actually doing it right.
When you do the I thing, you get positive I, negative I.
Good. All right. When you do the complex numbers, when you have a complex number as a 0, they come in conjugate pairs, which means it's how many of them? 2. That's why it goes down by 2. Okay? So if you have 2 sign changes, guess what? It's either 2 or 0. If you have 4 sign changes, it'd be what? 4, 2, or 0. If you have 1 sign change, guess how many you got? You got 1. All right? All right? When I test for negative real zeros, I substitute a negative x in. Okay? Just kind of like if we'd be testing for even and odd functions, kind of like that. So if it's an odd power, what happens? Does the negative get to come out to play? Yes. If it goes into an even power, it stays what it is. All right? So if I were to substitute a negative x, this would be a negative 6x cubed, right? And then if I were to substitute a negative x, this would still be a minus 4x squared. And then if I were to substitute a negative x, this would be a negative 3x. And then this would still chill as a negative 2. Do I have any sign changes going on? No. So what that tells me is I have 0 negative real zeros. What that just did is it eliminated half of our possibilities. Because when we find our P's and Q's, we do what? We do what? Plus or minus. All right? And so by Rene's rule, all right, or Josh, so by his rule, when we find our P's and Q's, I just need to test the what? The positive. All right? So that's actually pretty nice. All right? So what's my P's? 1 and 2. What are my Q's? 1, 2, 3, and 6. All right? So let's put it in that form. So now I have a 6, and a negative 4, and a 3, and a negative 2. And I want a remainder of 0. Would I test 1? I would not test 1. Why would I not test 1? Because the coefficients don't add up to 0. All right? So I don't even need to test that one. So what are we going to try? What are we going to try? 1/2. Let's try 1/2. So if I do a 1/2, I get a 6, and then a 3, and then a negative 1, and then a negative 1/2. I'm actually going to stop there because when I add this together, I'm going to get a half there, and then when I multiply by a half, I'm going to get a fourth. All right, so 1/2 isn't going to work for us. So 1/2, it's going to chill over there. All right, what else we want to try? You want to try 2? All right, let's try 2. So if I try 2, I get 12, and then I get 8, and then I get 16. And that's going to be pretty large. Can I stop? All right, so we tried 2. What else are we going to try? 1/3? Okay, let's try 1/3. So then I get a 2, and then a -2, and then I get a -2/3. Again, just like the 1/2, I'm going to get a third of some kind now. And so they actually get a 1/9. All right, so 1/3 isn't going to work. All right, now what do you want to try? 2/3. I'm feeling good about 2/3 too. I agree. All right, so let's try 2/3. So then I get 4, and then I get 0, and then I get, and then I get, and then I get, whoop, whoop. All right, so right there I end up having x minus 2/3. And then what does this 603 thing give us? That gives us a quadratic. That gives us 6x squared plus 3. All right. Now, this one's only asking for what? Real zeros. Is this 6x squared plus 3, when I set that thing equal to 0, is that going to give me a real 0? No. It's going to give me what kind? It's going to give me an imaginary. So I'm going to be done with that one. All right. So the only 0 that I found is what? 2/3, comma 0. All right. And then I'm done. So using Renee's rule, we're going to determine the possible positive and negative real zeros. And then we're actually going to find all the zeros. All right, we're going to take it a step further, even though it doesn't say it. So I have x cubed plus 2x squared plus 5x plus 4. How many positive real zeros do I have? Julian, how many positive real zeros do I have? I got 0. Why do I have 0 positive real zeros? Because there's no sign change. All right. So if this were me personally, if it didn't ask me to find the number of positive or negative real zeros, I would stop there and I would just do my negative p's and q's. All right, you following me? However, since this is doing it, I actually need to find my negative real zeros, so we're going to substitute in negative x. All right, it's good practice for us right now anyway. So when I substitute a negative x into an odd power, it changes the sign. So now I end up with negative x cubed plus 2x squared. Okay, because that's a squared, that's an even power, that stays the same. And then minus 5x, and then plus 4. So, is that a sign change? Is that a sign change? Is that a sign change? So what do you know? I have 3 or 1 negative real zero. We're going to find our p's and q's like normal, but what are they going to be? They're all going to be what this time? Negative. They're all going to be negative. All right. So what are my p's? 1, 2, and 4. What are my q's? 1. So I went from how many options? I went from 6 options now to what? 3. That's kind of nice. All right. That's kind of nice using Renee's rule. So now when I put it in synthetic, I'd have a 1 and a 2 and a 5 and a 4. All right. So what do we want to try? -1. All right. So we get 1 and then we get -1 and then we get 1 and then we get, then we get, and then we get, then we get, whoop, whoop. We're a winner. So I got to a quadratic. That's where I will always stop. So this -1 is actually an x plus 1. And then this 114 is actually an x squared plus x plus 4. All right. Two quadratics. We like to have them up. Will it factor? No. So we're done. Just kidding. What do we use? The quadratic formula. So x is equal to opposite b plus or minus the square root of b squared minus 4ac all over 2a. not 2a, silly goose. It'd just be what in this case? Just 2. All right. All right, so now we got to do a little bit of math. So 4 times 1 times 4 is 16. 1 minus 16 is negative 15. So what's going to come out? An I. So now I have negative 1 plus or minus I square root 15 all over 2. Now I'm going to make you go one more step further. So then I need to split that up into 2. So now I have negative 1 plus I square root 15 over 2, comma 0. And I have negative 1 minus I square root 15 over 2, comma 0. And what's my other 0 that I don't have written down yet? Negative 1, comma 0. All right. Pretty good? All right. All right, there you go.